U5 Trig review. Okay, first couple things we need to remember. So we need to remember our angles and parallel lines. So the first section on your unit assignment. So if I draw a couple parallel lines and I put a transversal through it, and I put A, B, C, D, E, F, G, and H, you need to know which ones are going to be, let's just move this over actually, grab the whole thing, move it all over there. So we need to know corresponding angles. So corresponding angles are going to be angles that are on the same side of the street. Meaning if I called this transversal line here the street, they'd be on the same side of the street and they're the same size. They are same size. So they're either under a parallel line or they're on top of a parallel line. So if I were to take a look right now, I would say A is corresponding with E because they're both on top of parallel lines and they're both on the same side. So we have A is equal to E, and I also have then C would be equal to G. On the right-hand side, who do we have would be equal? B equals F and D equals H. Good. Those are our corresponding angles. Then we're going to take a look at, I'm just going to unhighlight these guys right here for a moment. I'll redraw them in. A and E, so we have to give them new names. So now we're going to talk about alternate interior angles. Well, the first thing is they're between parallel lines. Okay, so they're between the parallel lines. And they're on opposite sides, and they form a Z or an N. So they are on opposite sides. Opposite sides of the transversal. And we're looking for the Z. So if I were to draw a Z up here, I'm going to highlight. Here's my Z. My alternate interiors are going to be C matches F. Okay, they are diagonal. They are going to be the same size. Okay, they're always the same size. So we've got C matches F. Those are your interior alternates because they're part of that Z. We also then have D and E that match. Okay, they're on opposite sides, but they're in between the parallel lines. Okay? So in between the parallel lines, what I mean is they're in between these two lines. So they're found in there, in the middle. Okay, that's what I mean. Then we need to do a co-interior. So, letter C is called the co-interiors. Co-interior angles. They're also between parallel lines. They're between parallel lines. They add to 180 degrees, and they form a C or backward C. Okay, they form a C or a backward C. So in this case, I'll let you write that down before I continue. Okay, so we have one last one on here, and that's supplementary angles. So supplementary angles are two angles and only two angles that add to equal 180 degree straight lines. So they form a straight line. Okay, so that's what happens. Supplementary angles add to a straight line. And when we go up to our diagram, I'll show you examples of that in a moment. Okay, so please just write those down right now.
Angels.
Now everybody on the video knows that too. That's Denny, by the way. Yeah, you. Okay. Supplementary angles, if we go up to our diagram, supplementary angles are going to be any angle that creates a straight line. So if I look up here making our green straight line, A plus B, they are supplementary. A and C are also supplementary. B and D are also supplementary because they would form a straight line, make 180. There's lots of supplementary on the diagram, okay? Across or up and down. Okay, up and down or across. Anything that makes a straight line. Okay? Okay, moving on from angles, we are now going to look at our basic right angle trigonometry. So this is going to be number 2, and we're going to talk about SOHCAHTOA. Okay, SOHCAHTOA is also written this way, so that we can see okay, I've color-coded them. The S, the C, and the T, the sine, cosine, tan, those are buttons on your calculator. Now, those are our trigonometry buttons for a right angle triangle. Now, the other formulas we need to know is the Pythagorean Theorem. A squared plus B squared equals C squared. And of course, the variation of the subtraction. So C squared minus one of the sides squared equals the other side squared. Okay, so this is A, B, and of course C is your hypotenuse. So now we have 3 new words, the O, the A, and the H. So O stands for opposite side. So it's going to be across from the angle. Okay, and then we've got the A, which is called your adjacent side. And this is the side that is between the 90-degree angle and the angle given, or the one you're asked to find. So the angle given or to find. Okay, so it's the side between the 90 and the angle to find. And then you've got H, of course, which is your hypotenuse. Which is, of course, always your longest side. And one other feature is the hypotenuse is always across from the 90-degree angle. Okay, so it's always across from it. Okay, so what we're going to do, push pause now so that you can have a moment to write those down. We're going to continue with an example. So our example we're starting with here, we have to remember how to label our triangle. So I'm going to draw a triangle here first, and we are going to solve for a side. So I'm just going to move it down. We're going to call it A, solving for a side. Okay, solving for a side. So let's say I've got 30 degrees here, and I've got X, and I have 6. So, first thing we're going to do, first step, label the triangle. Okay, so label the triangle and choose the correct equation. EQN is equation. Okay, so that's step one. So when we label the triangle, we're labeling it as OAH, the sides of our triangle. Now, how do we do it? We first always circle the angle. Given, we circle the angle given, or the one defined, or to find. In this case, we're given one because we're finding a side. Okay, so first step, circle the angle, we're going to label our sides. So if that's our angle, X has to be the adjacent side because it's between the 90 and the angle 30. 6 is across from 30, so he's the opposite side. I don't have a number on my H leg, I've not asked to find it, so I have O and A. So when I look at my SOHCAHTOA equations, I'm going to find I use tan. So I'm going to write tan of my angle. The angle always goes next to the word sine, cos, or tan. So I'm going to put my 30 degrees there, equals the fraction. And now I'm putting my O leg on top of my A leg because that's what it tells me in my equation. So I've got 6 on top of X. So now we have two situations. We're either going to be multiplying or dividing. When X is on the bottom, the short step is to take everything on the left and switch places with X. That includes taking the word sine, cos, or tan. So our equation's now going to look like this. X equals 6 divided by tan 30. And that's what you would put into your calculator. Don't forget, you must be in degree mode to do this trigonometry. Okay, so hopefully you've done all the math in your calculator, and if we are not told, we always round to the nearest one decimal place for side length. So we are going to get 10.4. So the side is 10.4 long. Now, so that was step one. We wrote down, we circled our angle, we labeled. The second step, let's just continue writing our steps down. I'm just going to move these guys over to the left a little bit to give you some more room here. Just a bit smaller. Okay, so step two then was we already chose the correct equation. So we chose the correct equation. Now we have to put the numbers into the equation. And now we have to decide if you're multiplying or dividing. Now again, the way you can tell if you're multiplying or dividing is if X is on top of the fraction or if X is on the bottom of the fraction. So, little hint here, X on the bottom equals divide. X on top equals multiply. Okay, so there's little quick notes for us. Okay, so we have X on the bottom or X on the top. So we had an X on the bottom situation, so we switch places with tan 30, and we ended up dividing. Okay, we're going to do one more question, only this time we're going to do a multiplying question. So our variable is going to end up on top. So let's take a look at example 2. So example 2, here's my diagram. I've got 40 degrees up in the corner. I've got 60 over on the right-hand side for my hypotenuse, and over here I've got X. So again, first step, locate your angle given or asked to find. So you circle your angle. Now we label the legs according to the angle we circled. So the guy across is the opposite. Across from the 90 is the hypotenuse, so not 60 is the hypotenuse. We're not given a number on the adjacent leg, so we don't even need to look at this guy, not even at all. So we look at our SOHCAHTOA, we're found O and H, so that's going to be sine. So now I write my sine equation. So I know S-O-H. So it's going to be sine of the angle goes next to the word, 40 degrees, equals, now my opposite, x over 60. So now that x is on top, we are going to take our bottom number and move it out front, and we're going to multiply it by sine 40. So in your calculator, you're going to put the number 60 on the bottom. He's going to be putting the calculator first. So we're going to get x equals 60 times sine 40 degrees. Okay, and again, round to 1 decimal place. Okay, so we should have got 38.6. So x equals 38.6. Okay, so that's finding side lengths. Now we're going to switch gears and we're going to start finding angles instead of side lengths. Okay, we're going to take a look at the next one, and that is solving for an angle. So if I need to solve for angles, again, we're going to start with our famous first step, and we are going to label the triangle by circling the missing angle that it wants us to find. Okay, second step, we are going to write the equation that matches the legs we are given. Okay, so we're going to write the equation that matches the information on the triangle. Are we given the O and the A, or the A and the H? What legs are we given? So we write the equation that matches, and then we substitute the numbers into the equation. Third step, we are going to now hit a special button first. It's called the second button. In order to solve an angle, we need to hit 2 buttons. So we're going to hit second, and then sine, cos, or tan, whichever it is. And then we're going to divide the fraction. Okay, and unless otherwise told, angles are rounded to the nearest whole number. Round to a whole number unless asked otherwise. Okay, so if it's stated otherwise in the question, do it the way it's stated. Otherwise, you're always going to be doing it to the nearest whole number for an angle. So let's take a look at an example of all 3 of these steps and put it all together. So here's example 1. Here's my triangle. Okay, they're not always going to be sitting upright. So I want to find theta there, a missing angle, and I've got 5 and I've got 2. So I now circle my angle, I circle this one, and I label the sides. I have the H and the A number given, A and H. So I look at my SOHCAHTOA and I have cos. Cos is A over H. So now I write my equation. Cos of the missing angle that I need to find, theta, equals, now you write your fraction, A over H, 2 over 5. So now, just so that I don't forget, I'm going to write the word second up there. And I'm going to put it right above the word cos so that I don't remember or don't forget to hit that button. Okay, so do the math and then check your work. Okay, everybody should have got 66 degrees. So angle theta equals 66 degrees. Now, if they asked us to solve the whole triangle, we do know that triangles add up to 180 degrees. So that means this angle and this angle have to add to 90, because 90 in the corner plus the other 290 have to equal 180 for the triangle. So if I were to ask to now find the other missing angle, let's call him sigma, well, I would take 180 and I would minus the 90, and I'd now minus the 66. So I'm going to find my other missing angle is going to be, angle sigma is going to be 24 degrees. And again, if we add both of these together, we should get 90 degrees, and we do. Okay, check your work, please. Now we're going to take a look at our next section. So these are right triangles. This is how we solve right triangles when we're given multiple triangles. So we now need to solve multiple right triangles. So number 3, multiple connected triangles. So I've got multiple connected triangles. Well, there's something we need to do first when we have connected triangles. We always need to find the size, or length, of course, because it's side length. So we need to find the size of where the two triangles are connected. Where the two triangles are connected. And that helps you solve the rest of the question. So that's what we always need to do. So let's take a look at an example. Okay, so we're going to take a look at our first example here. So you're going to notice we have a multiple triangle there. And we're going to label it. So this is the information they're giving us. Here's example 1. Okay, example 1. So let's put the information on it. We have a 90-degree angle. From here to here is only 35. We have 22 degrees here. And in this angle, right here, that little red angle, that is going to be 62 degrees, okay, in that little corner. So I've got an angle here, 62. I've got a giant triangle and a small triangle. So let's just take a look at both triangles for a moment. So I've got a large triangle, if everybody can see that one. And then I've got the small green one I'm going to shade in right now. So this small green triangle is inside the big yellow one. So again, like they say up in the very first sentence there, we're going to find the side they're joined by. So where do you find the two sides where they're joined? Well, they're joined right along here. So that since they're joined there, that's going to be the first side we're going to find. Because the question is going to ask us to find, we want to find Z. Well, in order to find Z, I need to find X of my other triangle first. So I'm going to use the green triangle, my small information, to find X. Then I've got an angle and a side for my big yellow triangle. So I'm going to separate them right now. So my small triangle looks like this. I have X, 62 degrees in the corner, and 35. So circle my angle, label, opposite, adjacent. I'm going to use tan. So I write tan of my angle, tan 62 degrees equals my opposite, X on top of 35. Now what we're going to do is we're going to take 35 out and we're going to multiply it by tan 62. And that's going to find us our big long scribbly line there, our squiggly blue line. So the side they're joined by, again we round to one decimal place always, is going to be 65.8. That's how tall that side is. So now I'm going to redraw the big yellow triangle. So on the big yellow triangle, I know that I've got, let's move this guy over, I just found I've got 65.8 for this big long side here, connected to the 90. I've got 22 degrees here. I need to now find the entire length of that side. Once I find the entire length, I can go back up to my question and I can subtract this other little piece, 35. And that's going to help me find Z. So I'm going to call this Y down here. So in order to find Z in the end, Z is going to be equal to Y, subtract that 35 piece. And that's how we're going to find Z. Because ultimately that's what we're trying to find, is just a little piece there, Z. So let's find Y first. Again, we're going to circle our angle and label our sides. Y is now the adjacent side between the 90 and the 22-degree angle. And then we've got the opposite side over here. So I'm using tan once again. But now I'm using it with a different angle. So I'm going to write tan of my angle, tan 22 degrees, equals my opposite side, 65.8 divided by y. Now, since y is on the bottom, we are now going to switch places. So we're dividing this time. Tan 22 and y are going to switch places. So in our calculators, we're going to take 65.8 and we're going to divide it by tan 22. Okay, and that's exactly what you're going to type in. When we do, we're going to get y is equal to 162.9. Always round to one decimal place. Okay, so now I know the entire length. And my idea is I need to find z. In order to find z, I need to be able to take y, which is this number right here. This is equal to my y. I need to subtract now 35. So in my equation, I'm now going to take 162.9 and I'm going to subtract 35. That's ultimately going to give me the size length of z. So in this case, z is going to be equal to 127.9. Okay? There was a question similar to this on the unit exam, and many people got as far as finding the big long side. You did well, and you found the long side, but then you forgot to subtract that little piece that was already there. So this little 35, it was a different number on the exam. Many people found the full distance, but forgot to find z, or subtract the z. Subtract 35 to find z. Because we did find that this entire way, from here to here, we called y. That's what we called the y way. Okay? So that's where all the numbers come from. Okay, that is solving multiple right triangles when they're connected. Now we're going to take a look at solving for non-right triangles. So this is number 3. Now we have non-right triangles. For non-right triangles, we only have 2 options, sine law or cosine law. So the first one we're going to take a look at is sine law. So sine law states that side A is across from sine A. Side B is across from sine of B, and side C is across from sine C. So literally it is a cross multiply and divide type of situation or ratio that you're going to set up. So when do you use the sine law? When do we use this? Well, we always use it when we have an opposite side pair. An opposite side angle pair on the triangle. As long as we've got an opposite side angle pair, we can use the sine law for anything. We can even use the sine law in right triangles, actually. Okay, so now let's do an example. So, example. Here's my triangle, and I have no right angles. That kind of looks like I have a right angle. Let's make it a little bit different. So we're going to make it stretch way out and come in. There we go. Now we definitely don't have any right angles. Okay. So I'm going to put 140 degrees right there. That's for this angle. And I'm going to put 203 centimeters for that length right here. I'm going to call this guy A, B, C. And I'm also going to put 30 degrees here. All right. Wrong corner, actually. 30 degrees has to go in the other corner, pardon me. So 30 degrees in that corner. Okay. The question's going to ask me to solve the triangle. So if I need to solve the triangle, I'm going to go across. So across from B is baby side B. Across from C is baby side C. So I need to solve for both of those. I can also solve side or angle C. Now angle C plus angle A and B have to add to 180 degrees. So angle C is equal to 180 minus 140 minus 30. That just leaves us 10 degrees. So C is going to be 10 degrees. Now we've got an opposite pair right here, and we're asked to find B, and B is across from his angle. So now we're going to set up our situation. So we've got 203 over sine of 140. That's his opposite pair. That's called our true ratio. The true ratio has a number on top and on the bottom. And that's the one that you are going to cross multiply with for all of the answers. So the next one, we want side B across from sine 30 degrees. And then we want side C across from sine 10 degrees. So it's written as a ratio with 3 fractions, but we take 2 of them at a time. And again, we need to use the true ratio. So I would cover this left side up, I would cover it up, and I would just use the 2 on the left. I would cross multiply and divide by there. Once I do that, that's going to give me side B. Okay, I'll give you a couple minutes. Please do the math. Okay, let's check our work here. So in order to solve side B, to find side B, you needed to type in 203 times sine 30. Then you needed to hit enter. Then divide by sine 140. Make sure you're hitting it in correctly and then enter. Make sure you're entering it correctly in your calculator. That's going to give you 157.9. It's a side length, so we go to 1 decimal place. So now we know B is equal to 157.9. Now I need to find C. So now I'm going to cover up the middle part, and I'm going to cross multiply 203 with sine 10. So now to find sine C, I'm going to take 203 again, but now I'm timesing it by sine 10 degrees, enter, divide by sine 140 degrees, enter. Okay, that's going to give us side C, again to 1 decimal place, 54.8. Okay, so now we go back up to our triangle, and we know that C is 54.8 degrees. Okay, check your work, do the math. Okay, now we're back to looking at the cosine law. So we just dealt with sine law. Now sine law could be for sides or angles. So if we wanted to find an angle, let's actually backtrack to that. We need to do another example so that we can find a missing angle actually. So we're going to find a missing angle. We're going to have 5 over here. We're going to have 48 degrees here. And we're going to have 7 right there. So this is example 2 under sine law. We're again going to check for opposites. So there's no labeling of sides when you have sine law and cosine law because there's no right angle to compare to. So we always just find your opposite pairs. So finding an opposite pair, now I write my equation. So I've got 5 on top of sine of, we have no idea, theta. And then we have 7 on top of sine 48. Okay. Now there's only one extra step in this situation when we're looking for an angle. So we're going to cross multiply this way, and then we're going to divide by 7. That's going to give us a decimal. So we're going to take sine theta equals 5 times sine 48. Then you have to hit enter. Then you hit divide by 7. Then enter. And again, that's going to be sine theta. It's a decimal, okay? Because we're going to be looking for an angle. So let's do our math, please. Okay, so when we get that, we're going to get a decimal, 0.5308, yada, yada, yada. It runs on forever. In this step in your calculator, don't change it. Now what you're going to do is you're going to go second sine, second, and then your negative button, which is answer, ANS. It's going to take that answer, but it's going to take the entire decimal, which is what we want. So you want an accurate reading. So that's going to give us angle theta. and angles we round to the nearest degree. That's going to give us 32 degrees for angle theta. So now if we want, we can find our third missing angle by going 180 degrees minus 48 degrees minus 32 degrees. And that's going to give us 100 degrees. So your missing angle is 100 degrees. Okay, so just one little separate step in there, the second sign, second answer when we're looking for an angle. Okay, check your work on that, please. Make sure you've written it down properly, practice the buttons. Now we're going to take a look at this cosine law. So B, cosine law. Now, when do we use the cosine law? Okay, well, we use it when we've got only sides and we're looking for an angle. So 5, 6, 7. Or we have no opposite pair. Okay, so no opposite pair of angle and side. Angle, side. Okay? Because if we had an opposite pair with angle and side, we could use the sine law, but we don't. So we have this situation, or we would have this situation, x, and I call it the taco. The taco because you've got a number and an angle. So we've got, let's say, 36 degrees here, and he's tacoed in between two sides. So let's say this guy's a 12 and this guy's a 17. Okay, so 12 and 17 surround or taco the 36. That's the situation. And again, take a look, we have no opposite pairs. There's no true ratio to be an opposite. So again, this is why we have to use the cosine law. Now, with the sine law, there was one equation, and we just cross-multiplied and divided. With cosine law, there are two equations. One to solve a side, and one to find an angle. And we're going to do one of each. Okay. Let's take a look at finding an angle first. So example 1 is going to be finding an angle. So here is my triangle. I'm going to have 25.8 over here, 31 here, and 30 here. And I want to find angle theta. Well, in order to do that, as we know we have no opposite pairs, I'm going to use the cosine law. So the cosine law I'm going to use is this one. It says cos of A is equal to B squared plus C squared minus A squared, all divided by 2 times B times C. Okay? That's the way it should be. So, let's just take a look at our bottom there. I want to move him up. Oh, he's connected. That's okay. Okay, so that's the equation we're going to use. They don't show you brackets on the formula sheet, but you need to remember that if it's a fraction, you need to solve the top to one answer, solve the bottom to another answer. That's why they have to be in brackets, because there's more than one number on top and more than one number on the bottom. Now, the part that makes this unique is you have to match the numbers very, very carefully. If you're looking for the angle, the side across from him is the number that is subtracted in the equation. The two sides that are the taco numbers, so the guys that taco, these two sides here, they show up as B and C on the top and the bottom. Okay? So they surround the angle. So let's put our numbers in the equation and find out how large our angle is. So again, we're going to get a ratio. We're going to get cos of A is equal to a decimal is what we're going to get. So again, finding an angle, our last step would be second cos, second answer. So let's just throw these numbers in the equation real quick. So we've got the numbers that are tacoing, 30 squared plus 31 squared minus the guy across, which is 25.8. And again, we have to square him, because that's what the equation says. And then 2 times the first two numbers, 30 times 31. And that's exactly how we type it in a calculator. Okay, I'll give you a couple minutes to type that in. Okay, so now we're going to get cos of A is going to equal this big long decimal, 0.642, and then 6 repeated. So again, we're going to go second cos, second negative sign, which is answer. And that's going to give us 50 degrees, round to the nearest whole degree, of course. So 50 degrees. Now, if I go up to my diagram, that means now that theta, I can erase theta, and I can put in 50 degrees. So I now know that theta is 50 degrees. So once you've solved one part of it, and if it says solve the entire triangle, if it wants to solve angle x and y, you now have an opposite pair to do so. But you have to use the cosine law first. And then you switch to sine law. Okay, we're going to do one more example, and the other example now is going to be finding a side length, not an angle, because we have a second example and a second equation. So, example 2, we're going to find a side, and we have to use this equation. So the equation looks like this on the formula sheet. B squared plus C squared minus 2BC cos A. Now remember, when they're side by side, they mean times. So it's 2 times B times C times cos of A. Again, because our calculators are pretty smart, we can throw it all into one step. So what I would have you do is I would have you take the entire equation, and what I would ask you to do is I would ask you to erase the squared sign on the first, and then put the whole thing under the root sign. The squared signs under the root sign have to stay. It's just the squared sign on the outside that disappears. So the guy on the outside disappears and becomes a hidden one now. Okay, now what we're going to do, when do we do this? Again, we do this when we're finding the taco side. So again, maybe I've got 30 degrees, a 5, and a 6, and I need to find the side across from him. So we're going to do actually that example. So I'm trying to find the side across. All I literally do is put my numbers where they go. There's only one angle, so that's the angle that goes where the A is right there. So in my calculator, I would type in this part exactly. 5 squared plus 6 squared minus 2 times 5 times 6 times cos 30. And that's going to give you your answer right away, okay, because it's under the radical side, which means it's going to be taking the square root of our answer right away, which is what we want. Okay, so everybody practice that. Solve for A. Okay, we're going to get 3.0064, yada, yada, yada. And again, we go to one decimal place. So nothing round, we would say A is 3. Okay? Check your work, make sure you got the same answer. This concludes trigonometry review.